So this video is going to be on finding the linear terms of a polynomial and finding the zeros of the polynomial using rational zeros and also some review of complex numbers, but very basically for the purposes of polynomials. So let's consider that we have a polynomial p of x equal to 4x cubed plus 16x squared minus 16x plus 20. We want to be systematic in how we're going to go through and to factor this and also to find its zeros. What I first want to do is I first want to find the greatest common factor and then go through and factor out that greatest common factor. So p of x is going to equal then 4 times x cubed plus 16x squared, plus 4x squared minus 4x plus 5. Okay? Now the great thing about this is that once it's been completely factored out, we're now going to go through and we're going to find the zeros. The 4 here doesn't play a role inside of finding those zeros. Only thing that plays a role here is x cubed plus 4x squared minus 4x plus 5, because that polynomial is going to have the same zeros as p of x. Okay? So we're going to take those. So what we'll do is we're now going to use, step 2, is we're going to use the rational zeros to find the zero of the polynomial. In order to do that, the first step is to find the factors of the highest degree of the polynomial and the constant term of the polynomial. So we have x cubed plus 4x squared minus 4x plus 5. The constant term is a 1, so its factors are 1 and negative 1. The constant term is a 5, so its factors are 5, negative 5, 1, and negative 1. Okay, so now I've written them all down. According to the rational zeros, all of our possible rational zeros will be 5 as the numerator of the function and 1 or negative 1, or the factors of 1 as the denominator of the fraction. So we're going to write down all of our possible zeros. This doesn't mean that they actually are zeros, it just means that they're possible zeros. So I'll start with 5, and 5 will be divided by 1 and negative 1. So I have 5 divided by 1, 5 divided by negative 1. Then I can take negative 5 divided by 1 and negative 5 divided by 1, but in truth, that's going to be exactly the same. That's going to be 5 and negative 5, so I don't need to actually list those. Okay? So I'm just going to go through and I'm going to take my 1 and my negative 1. So I'm going to have 1 divided by 1 and 1 divided by negative 1. When I go through and simplify, these guys are going to give me my possible rational zeros of 5, negative 5, 1, and negative 1. Okay? So now that I have all of my possible rational zeros, what I'm going to do next is I'm going to input those in to see if it is a true zero. So the value I have x cubed plus 4x squared plus, or minus 4x plus 5. Okay. So I'll start out with 5. Okay. By selecting 5, I'm now going to plug that in. That's going to give me 5 cubed plus 4 times 5 squared minus 4 times 5 plus 5. Okay. And that'll equal 125 plus 100 minus 20 plus 5. Well, when I take that, that's going to end up giving me 210. That's not equal to 0, so that means that that's not a 0. Okay, let's try negative 5 then. Negative 5, I'll take negative 5 cubed plus 4 times negative 5 squared minus 4 times negative 5 plus 5. This is now going to equal negative 125 plus 100 plus 20 plus 5, which does equal 0, which means that I found my first zero. My first zero is going to be x equals 5. Now, what I want to do with that now is I actually want to go through and do some simplification in order to simplify my polynomial before I go find other zeros. Now it turns out the other zeros are either going to be 1 or -1. But like I said, I'm going to do my factoring first and see what I get. Okay, so I'm now going to factor out the 5, or excuse me, x equals -5, not 5. And I'm going to use, for the purposes of this discussion, I'm going to use synthetic division. So I have -5 right here. That's my 0. Okay, and then the coefficients of the polynomial 1, 4, -4, and 5. Okay. All right. Bring down my 1. -1 times 5, that's -5. We'll add those two together. That gives me -1. Then -5 times -1, that's going to give me +5. Gives me a 1. And then -5 times 1 is going to give me -5. And so that's now a 0. That means that when I do this division, I'm going to get x squared minus x plus 1. And that's my new polynomial. Okay? Now, what we'll do is we'll continue to use numbers 3 and 4. We'll continue to use, or actually, numbers 3 and 4. That is, we'll use rational zeros to go through and find a 0, and then we'll use either synthetic division or long division to go out and factor the terms until we reach a quadratic. Because once we reach a quadratic, then it's really quite easy to work with. Okay, then we can just use the quadratic equation. And this is just the fastest way of going about factoring these polynomials. So now I have x squared minus x plus 1. I want to use the quadratic equation, so I'm going to set that equal to 0. And that means that a is going to equal 1, b will equal -1, and c equals 1. Using the quadratic equation, x will equal -1 plus or minus the square root of -1 squared minus 4 times 1 times 1 all over 2 times 1. When I simplify that, I'm going to end up with -1, or excuse me, +1, plus or minus the square root of 1 minus 4 all over 2, which equals 1 plus or minus the square root of -3 all over 2. Now, what I have here is I have a complex number. If you notice, it's the square root of -3, so this is going to equal 1 plus or minus the square root of -1 times 3. And then I know that this all over 2, which equals 1 plus or minus the square root of -1 times the square root of 3 all over 2. And so this is going to equal 1 plus or minus, we'll transform square root of -1 into an I root 3 over 2. And that gives me my last two. My last two zeros are x equals 1 plus I root 3 over 2 and 1 minus I root 3 over 2. All right, so now I have how many? I have 1. Here's my first zero. 2, second zero. And my -5, there's my third zero. So those are all the zeros of the polynomial. Okay, so I'm going to write those down. I have x equals 5, 1 plus I root 3 over 2, and 1 minus I root 3 over 2. Okay, those are all my zeros. Now what I need to do is I want to factor those into linear terms and bring that 4 back in. So each term, right, if a is a 0, then x minus a is a linear term. So that's the easiest way to think about this, right? And what we want to do is we're just going to take p of x is then going to equal, take my 4, don't forget my 4, I had that originally, and then x minus a -5 times x minus 1 plus I root 3 over 2 times x minus, this is parentheses, 1 minus I root 3 over 2. And that is my entire polynomial factored as linear terms. Couple things to notice, right? Since the degree of the polynomial is 3, I will have 3 linear terms and 3 zeros. All right, 3 and only 3. For all the degrees, for each degree of the polynomial, you will have a 0 and or a linear term. Okay? Now, a couple things, couple notes. If you write down, right, this is only partially correct. For times x plus 5, right, times x squared plus x squared minus x, minus x plus 1. The reason why that's only partially correct is because this is not factored. We need to factor it into complex terms because we are able to do that, and so consequently you need to make sure that you do that, otherwise you're only going to get partial credit. I'll take points off for doing that. Okay? So you need to factor to linear terms. And there we go. That completes it.